Good day, my friends. Today we'll be looking at the creature that can send chills down anyone's spine. Yes, I'm referring to this beauty right here. Say hello to the anglerfish. The anglerfish species consists of about 200 individuals, but in this instance we'll be referring to the common deep sea variety. By far one of my favorite deep sea creatures. I've always found their lure to be alluring. Once again, we'll tackle appearance, biology, history, and fun facts. I thank SadCod7874 for this suggestion. Without further ado, let us commence. Appearance. The common anglerfish is colored with a dark shade of brown or maroon. Their body lacks scales, instead they bear smooth skin that appears to have a leathery texture. They have large heads in comparison to the rest of their body. A mouth filled with rows of sharp, transparent teeth. Small beady eyes, typically a dull grayish color. Females can range in size from less than a foot to 3.3 feet long. Males are about 1 inch or 3 centimeters long. And of course, the iconic lure, which most certainly gives off that wiggly, tasty, warm vibe. I would best describe them as floating meatballs with a mouthful of teeth and a little light bug as their captain in the dark. Biology. Gender differences. Before we talk about the specifics of the lure, we must first address the differences between male and female deep sea anglers. Males are drastically much smaller and lack the iconic glowing lure these species are known for. They also tend to have an improved sense of smell and sight compared to females, and in some cases lack the ability to hunt. More on that later. Typically, males never mature, and die if they cannot find a female. You'll find out why soon if you don't already know. Females tend to be the heavyweights in this species, dwarfing males significantly, usually by 10 times. They also are the bearers of the iconic lure. The lure. The lure of a female, also known as a iliceum or iliceum, is a modified spine of the dorsal or back fin that has moved forward onto the top of the head. At the tip of the iliceum is a fleshy enlargement known as the esca, which is used to lure prey within range of the angler's dagger-shaped teeth. The lure, or iliceum, can be moved in a wide range of directions thanks to 5 distinct pairs of muscles, namely the shorter erector and depressor muscles that dictate movement of the iliceal bone, along with inclinator, protractor, and retractor muscles that aid motion. The lure's source of light is symbiotic bacteria that dwell in and around the esca, or fleshy tip of the lure, enclosed in a cup-shaped reflector containing crystals. Only a handful of luminescent symbiont species can associate with deep-sea anglers. In some species, the bacteria recruited to the esca are incapable of luminescence, independent of the anglerfish, suggesting that they have developed a symbiotic relationship, and the bacteria are unable to synthesize all of the chemicals necessary for luminescence on their own. They depend on the fish to make up the difference. The esca is always open to the surrounding environment, so it is possible that the fish acquires the bacteria from the seawater. However, it appears that each species of anglers uses its own particular species of bacteria, and these bacteria have never been found in seawater. It's been theorized that the esca discharges bacteria during spawning, and the bacteria are thereby transferred to the eggs. However, some evidence also shows that some anglers acquired their bioluminescent symbionts from the local environment. In a study on anglers in the Gulf of Mexico, researchers noticed that the confirmed host-associated bioluminescent microbes are not present in the larval specimens, and throughout host development, the anglers likely acquired their bioluminescent symbionts from the seawater. Photobacterium phosphoreum and members from the Kishitani clade constitute the major or sole bioluminescent symbiont of several families of deep-sea luminous fishes. Perhaps one day we can find the definitive answer with a bit more research and time. Teeth. In most species, a wide mouth extends all around the anterior or front circumference of the head, and bands of inwardly inclined teeth line both jaws. The teeth can be depressed so as to offer no restrictions to any object gliding towards the stomach, but prevent its escape from the mouth. The anglerfish is able to distend or stretch both its jaw and its stomach, since its bones are thin and flexible to enormous size, allowing it to swallow prey up to twice as large as its entire body. Because of the limited amount of food available in the angler's environment, this adaptation allows the angler to store food when there is an abundance. Reproduction. These fish by far have one of the most unique and unusual reproductive stories. In many species of anglers, the male seeks out the female with their enhanced sense of smell to whiff out the female's pheromones, as well as using their advanced vision to lock onto the female's lure gestures in the dark. Once the male finds his match, he bites into her skin and releases an enzyme that digests the skin of his mouth and her body, fusing the pair down to the blood vessel level. The male becomes dependent on the female for survival by receiving nutrients via their shared circulatory system and provides sperm to the female in return. This extreme sexual dimorphism ensures that when the female is ready to spawn, she has a mate immediately available. Multiple males can be incorporated into a single individual female, with up to 8 males in some species, although there are others that appear to have a 1 male per female role. The spawn of the anglerfish, in this case that of the genus Lophius, consists of a thin sheet of transparent gelatinous material, 25 centimeters or about 10 inches wide, and at times greater than 10 meters or 33 feet long. Such an egg sheet is rare among fish. The eggs in this sheet are in a single layer, each in its own cavity. The spawn is free in the sea. The larvae are free swimming and have the pelvic fin elongated into filaments. Behavior. An ROV filmed a female angler of the genus Onirodes for 24 minutes. When approached, the fish retreated rapidly. But in 74% of the video footage, it drifted passively, oriented at any angle. When advancing, it swam intermittently at a speed of 0.24 body lengths per second, beating its pectoral fins in phase. The lethargic behavior of this ambush predator is suited to the energy-poor environment of the deep sea. Another observation of 3 different whip-nose anglers showed unusual inverted swing behavior. Fish were observed floating inverted, completely motionless, with the elysium hanging down stiffly in a slight arch in front of the fish. The elysium was hanging over small visible burrows. It was suggested this is an effort to entice prey, an example of low-energy, opportunistic foraging and predation. When the ROV approached the fish, they exhibited burst swimming, still inverted. History. In 1833, an almost perfectly spherical fish washed ashore in Greenland and was taken to a zoologist, Johannes Christopher Hagman Reinhardt, in Copenhagen, Denmark. This fish, later known as the football fish or the man gobbler, was the first angler known to science. The earliest fossil of anglerfish are known from the Eocene Monte Bolca formation of Italy, and these already show significant diversification into the modern families that make up the order. Given this and their close relationship to the tetraodontiforms or ray-finned fish, which are known from Cretaceous fossils, they likely originated during the Cretaceous. Fun facts. Predators. Given their spooky appearance, they actually have a decent amount of predators. Crabs, sperm whales, deep-sea cephalopods, deep-sea sharks, larger fish, and yours truly, humans. worlds. Prey. Their prey consists of squids, crustaceans, snails, smaller fish, and occasionally decaying matter they may come across. Human consumption. One family, the Lophidae, is of commercial interest within fisheries found in Western Europe, Eastern North America, Africa, and East Asia. In Europe and North America, the tail meat of the genus Lophius, known as monkfish or goosefish in North America, is widely used in cooking and is often compared to lobster tail in terms of taste and texture. In Africa, the countries of Namibia and the Republic of South Africa record the highest catches. In Asia, especially Japan, monkfish liver, known as ankimo, is considered a delicacy. Anglerfish is especially heavily consumed in South Korea, where it is featured as the main ingredient in dishes such as agjim, also known as braised spicy angler. Where they live. Anglerfish live in a variety of environments, from shallow tropical waters to the murky depths of the ocean. They can be found in the Atlantic and Antarctic Oceans, the Mediterranean and Black Seas, the Barents Sea, and the northern parts of Western Africa. Their death range is influenced by the seasons and the age of the fish, as well as water temperature and prey availability. Some species can live as low as the continental shelf, while others can migrate down to depths of 2,000 meters to spawn. They typically live in the midnight zone, which lies below the twilight zone. The midnight zone is completely devoid of sunlight, but is not a problem for this resourceful fish. So in conclusion, I think we can all agree this fish is an oddball, but also very intriguing with how it operates in the darkest parts of the ocean. I'm just glad they're not on the larger side. Thank you all once again for tuning in. I did see a few suggestions in the last video and I've added them to the list. So if you all have any others, I'm open ears. Good night, fellow explorers, till next time.